Okay, let's continue by doing an example of a division of fractions problem. So I'm going to show you a way that hopefully will help you remember that when you have a division problem, basically we're going to turn it into a multiplication problem, and we multiply the inverse of the second fraction. So one way you could do this to help you remember what you need to do is we're going to write this, and it's going to look scary at first, but you're going to need to get used to it. So we have 4/3, basically 4/3 divided by 2/3. We want to get rid of this division sign, so this is going to turn into 4/3, and we'll just make kind of a big division mark here so you can see it, divided by 2/3. Okay, so this is what is called a complex fraction. When you have a fraction over a fraction, it looks complicated, so we call it a complex fraction. What we really want to do is we want to try to get this to be 1. Remember from the first example we had from the first video, any number over 1 is just that whole number. So it's basically going to be, we want what is up here at top, and we want this to become 1. Well, how do we do that? Well, how would we get this to 1? If you look at number 3, we can multiply this by its reciprocal. So the reciprocal of 2/3 is 3/2. But remember, what you do to one side, or 1/2, you have to do to the other so that we are multiplying it by 1. So this is taking care of what we did for number 2. This is the same as this. Let's say this is n over n equals 1. So we're not changing the problem any by multiplying it by 1. But this causes something to happen. What is 2/3 times 3/2? Well, if you look at number 3, that is the reciprocal, and that's going to force that to become 1. So now we have a 1 on the bottom here, and we have our big fraction bar. And now we have this problem here. 4/3 times 3/2. Well, that's funny. That looks like the same thing we have here when we invert and multiply. So that's essentially what you're going to do, because now we can get rid of this. This is the same as number 1. You can just write it as a whole number, or in this case it's going to be 4/3 times 3/2. So that is how you can get from a division problem into a multiplication problem, and then go ahead and solve it as multiplication. Let's take a look at this another way. We've already got it set up as a complex fraction, and we're going to say that is equal to a. Well, if you looked at the definition for fractional division, you can also say that this is 4/3 is equal to 2/3 times a. It's that analogy again of if this was 63 and this was 9, then this ends up being 4. Well, 36 and 9, this is 4. So this would be 36 is equal to 9 times 4. All right? Well, if we want to isolate a, this is kind of an algebraic explanation. If we want to get a by itself, well, I need to get rid of this 2/3 and put it over here. Well, how do I get rid of 2/3? I turn it into 1. And how do I turn this into 1? I multiply it by its reciprocal. So I'm going to multiply this by 3/2. But again, if you do something to one side of the equal sign, you've got to do it to the other side. So I have to multiply this side by 3/2. Well, here again is what we have at the top. 3/2 times 4/3, or 4/3 times 3/2. But now we are back to what we had at the top of the page, which is the inversion, taking that 2/3 and making it 3/2. All right, so go ahead and try a couple of practice problems that I have for you, and we'll talk about the actual number line proof in class.